everybody. We are here to have a topic-based discussion about the position of hydrogen in the periodic table of the elements. So I will now like to start. Before we begin, I would like to say the rules of the rules of this debate. The rules of this debate are as follows. Every if any or if audience has any questions, they have to raise their hands. They will be allowed to speak, including the participants. The participants also have to raise their hands before they speak. Next, second of all, we will begin with the alkali group and then the halogen group, and then we will take questions, or if the audience wants to present any independent topics that are independent of the topics given in the discussed in the debate, they can do the same. Now, I would like to hand over the mic to Naysha, who will begin the debate by explaining the periodic table of the elements.
Hi folks, I'm Naysha and today we're going to have a discussion on the position of hydrogen in the periodic table. So, hydrogen is the first element in the periodic table. As you can see, the top in the first group. Yeah. So, it is the first element in the periodic table. Its atomic number is 1 and it has only one electron in its valence shell. Therefore, it belongs to the first group and the first period in the periodic table. It is expected that the properties of hydrogen should be similar to those of the other elements of the first group. But this is not the case. Ever since Mendeleev presented his periodic table, the position of hydrogen in the table has been a matter of debate. This is mainly because some of the properties of hydrogen resemble the properties of group 1, which are alkali metals, and some of the properties represent of the halogens, group 17. Thomson suggested to separate position of hydrogen. He puts it at the top of the periodic table, which does not disturb the symmetry of the modern periodic table.
Okay, I would like to begin with alkali metals. I would like to ask whether Dhairya or Rutuja would like to speak first.
So I will speak first for the alkaline metal.
Okay, so we will begin by Dhairya.
Hydrogen should be in the first group.
Dhairya, sorry to interrupt you. Dhairya, sorry to interrupt you, but please allow me to say a few points before you begin. When Dhairya is presenting his points, I ask everybody not to interject him in between. Second of all, after Dhairya is done speaking his points, kindly raise your hands if you have any questions or would you like to present any interjections to his points. Thank you. Please begin, Dhairya.
I like to say that hydrogen should be in first group alkaline metal itself. It's because of hydrogen is the first element which has only one electron in its valence shell. Its properties also match up with with the alkaline metals, and it is the lightest metal. So and it should represent the periodic table. Hence, hydrogen should be in the first group.
Rutuja, would you like to present points?
Yes.
Okay,
so hydrogen should be in the first egg, that is the alkali metals group, because its electronic. The hydrogen should be in the first group, that is the alkaline metals, because its electronic configuration is 1, which is similar to the valence electrons of all the other alkali metals. For this, I would like to show a slide. For that, Naysha will have to stop sharing. Okay, thank you, Naysha. 1 minute. So now hydrogen, like all other alkaline metals, has 1 electron in its outermost shell, and so I feel that hydrogen should be kept in the first A group. Thank you. I'm done.
Okay. Are you done?
Yes.
Okay. Now we will move on to halogens. I would like to ask whether Arushi or Anshul would like to speak first.
Anshul would like to. Okay, I will speak first.
Okay.
Yeah.
Do you have do you need to share the screen, or would you
No, I do not.
you don't want to?
No.
Okay, it's okay.
Okay. So you said something about how the properties of alkali metals are very similar to the properties of hydrogen. Now, to some extent, that is correct, but you cannot forget how some of the properties actually differ. Now, a variety of the properties of alkali metals and hydrogen is actually very similar. Now, when we talk about properties, we talk about chemical and physical properties such as solubility, melting point, and etc. So the biggest thing is the physical state of halogens is actually very similar to the physical state of hydrogens. Now, the first two elements in the halogen, which is fluorine and chlorine, are both gases, and they are similar to hydrogen. Now, the reason it shouldn't be in alkali metals is because all of the alkali metals are, first of all, as the name implies, metals, and second of all, they are solids. So the physical state differs. Now, talking about the other chemical properties, we can talk about the solubility. Alkali metals are soluble in water, as we all know. Now, talking about halogens. Halogens are not soluble in water. And hydrogen is soluble in water, but we can say that it's slightly soluble in water. So one of the chemical properties is matching. Now, in a lot of the reactions, in the properties of hydrogen and halogens are so similar that in a lot of the reactions, such as the reaction between methane, halogens can be replaced by hydrogen and hydrogen can be replaced by halogen. And I don't think we can do that with many alkali metals. The melting point of alkali metals is actually really high, around 1,300. It goes high. And the melting point of halogens is minus 188 degrees Celsius. And for hydrogen, it's minus 252 degrees Celsius. So you can see that it's actually comparable, and you cannot compare minus within such 1,000. So I think that if it's as far as properties go, I think it has more properties related to halogens than alkali metals.
Now I would like to ask if anybody has any questions. Then please raise your hand. Do not unmute yourself and ask the question before raising the hand. Okay, Krish has a question. Krish, please unmute yourself and continue.
I don't have a question, but I have to say that as we are in discussion, why can't we keep hydrogen in the middle of first and 17th group?
Krish, if you don't have a question right now, you will get your chance. Please hold your question for some time. We will give you a chance to present your points. Does anybody have any questions opposing Arushi's points, including the alkali metal group? If you have any interjections to Arushi's points, please raise your hand. So you don't have any interjections to Arushi's points. Okay, moving on. Now from the alkali metals, if anyone would like to speak, please unmute yourself and continue. Dhairya, please wait. Your voice isn't audible properly, so that we will give you some time so your internet connection gets sorted. Now we will allow Krish to present his points. Thank you.
So as we were having a discussion between group 1 alkalis and group 17 halogens, so to tell that, why can't we keep hydrogen in the between of them?
I have a question for you, Krish. Do you have any points to prove your question?
Not exactly.
Not exactly, right? The whole point of audience giving their independent opinions about this is to, if you want to ask them a question regarding their points, you can ask the same. But if you have an independent point completely different from their point, you can if you have enough point, if you have researched enough, well enough, you can present those points right now, or else you can ask a question, proper question regarding their points to the participants. Now I see your question is, why can't it be in the middle? So I have to ask I have to ask our participants if they would like to answer this question, or would you like to say, if do you want to address it to anybody specific, or do you just have a question? Krish, Krish, kindly unmute yourself.
That's not my question, that's my opinion.
Do you have any points to present your opinion?
Yeah, that it should be between both of the groups.
Yeah, I know you want it to be between, but do you have any points supporting your theory that it should be in between?
Yes.
Yeah, kindly present those points.
Hydrogen should be kept in the middle of periodic table, as it has both the properties of alkaline and halogens.
That's it, Krish.
Yeah.
Okay, now anybody would have any questions for Krish's 1 point, kindly raise your hands and we will answer it. I see that Naysha has raised her hand. Now I'm going to allow Naysha to unmute herself and ask her question.
Yeah, so it's not a question exactly, but I wanted to say that why can't we keep it in the middle like Thomson did?
Okay, do you have any points? Because see, if you who are you addressing this question to? Please, please, if you have any question, address it to somebody. Just don't speak out your question without any points.
See, as I said, it's not a question, it's just my opinion. Like, what
Okay,
did Thomson
do
did it?
you have any points to support your opinion?
Yeah, sure.
Yeah,
Like,
please.
just like what Krish said, that it has the hydrogen has the properties of both alkali as well as the halogens, and as well as if we keep hydrogen in the middle, it does not disturb the symmetry of the periodic table. So why can't we do it like Thomson did?
Okay, I would like to stop you right there, Naisha. I would like to say this one thing. See, these the participants, they have prepared well. What you're not presenting an opinion, you're asking a question. Okay, it's a question that it has the properties of both halogens and alkali metals. Why it shouldn't be in between? You need to have points that support it. You are just saying that it has properties of both. It has properties of both, and JJ Thompson put it in the middle. So why can't we? So it's a question. Present your points in a way that it's the answer to your question. And if you want to ask this question to somebody in the participants group, you address it to them like that only. Please don't ask such questions to the entire group which you can't support with your own opinion. Hello?
No, it's not a question. It should be in the between. It should be in the middle, right? You're not understanding my point.
Exactly.
Look, I understand your point. It's been great. Okay, I get it. Okay, it's your point you have proven. Does anybody have any questions opposing, or would you like to ask a question to Naisha? Kindly raise your hand. Okay, I see that Rutuja wants to ask a question to Naisha. Krish, would you also like to take?
No, not ask. I can answer. I can answer Chris' question. Like
Okay,
it cannot be placed in between the periodic table because doing so will disturb the symmetry of the periodic table. I know it's not a really valid answer, but then it is a reason.
Okay.
Hydrogen is not put in between.
We are moving on to the teams again. Dhairya, is your internet problem sorted?
Yes, it is sorted now. So
Okay, Dhairya, present your points properly.
yes, I want to share the screen. So yes.
Please share. The screen share is enabled.
Yeah, okay. So is it visible?
Just a second. Yes, it is visible.
Okay, so as we all know that the valence electrons in the valence shell of hydrogen is only one, and it needs to lose one electron so it could be stable, and this takes place with all other alkaline metal. So because of the electrons present in the valence shell, the similarity due to the similarity, it should be in the alkalized metal, the group one.
Dhairya,
Yes.
please switch on your cameras and represent the points. Please do not turn off your cameras.
My camera
His camera is on.
There are
Problem
two.
with you and Tanish.
Dhairya's
Please
camera
pin
is
the
on.
second one. Please pin the second one.
Yeah, it is on.
Oh, okay.
On.
Thanks.
Okay.
Continue.
So yes, can I say it again?
Yes, please say it again.
Okay, so because hydrogen needs only one electron, because hydrogen needs to lose only one electron, then it could be stable. And this property is similar with all other elements of the group 1. Means if they lose one electron, they would be stable. And hence hydrogen is in group 1. And that's all.
That's all. I
Yes.
would like to ask the audience if they have any questions. Kindly raise your hands. I see that Rutuja has raised her hand. Okay. I see
Wait,
Arushi has a question.
wait. Okay, sir, can you just edit this? I need to get the phone. Like, I don't have the phone and I have to turn off my camera. So I'll just get the phone. Really sorry.
Okay, Arushi, you can turn off your phone. Oh, sorry, camera. Anshul, do you have a question? Please unmute yourself and continue.
Yes, I don't have any question, but I want to say that I get Dhairya's point. He's saying that the outermost orbits have one electrons, but see if we see in hydrogen and halogens they have one electron less than the nearest inert gases in front of like hydrogen is the outermost shell has one electron, and in helium it has only two electrons in the outermost shell. So for halogens and hydrogen, they need one electron in the outermost shell to attain stability.
Yes, that's true. But even in group 1, they only need one electron to lose, so they can gain stability now. So even both points are right. And as we know that properties, that hydrogen also matches with properties of halogens and group 1 alkalis metal. So that's okay. Let's see further in the debate.
Okay, now Arushi has to say something. Please unmute yourself.
So, yeah, you're right. It matches of both, but okay. So you said that the properties of alkaline metals and hydrogen matches, and you also said that it matches in halogen. So then, if we're going to take a neutral side, then what's the point of debating on it? Because according to me, the physical properties and the chemical properties are both equally important, and I believe that hydrogen and halogens have chemical properties with physical properties. So yeah.
Okay, because if hydrogen loses its one electron, it would be the first stabilized gas which has zero electrons in its valence shell if it loses its ones and gains stability. And if it is the first, it should be in the first group.
Okay. Okay. Does anybody have any further questions? We have time for just one more question, please. Move on to the other teams now. I see there are no questions. Now I'm going to ask Anshul, since he hasn't presented his points yet, to kindly present your point.
Yes, thank you, Tanish.
Anshul is of team halogens. Anshul will be presenting the points on behalf of the halogens team. Please continue.
Yes. See, hydrogen and halogens, these both are non-metals and they act as electronegative character. They have their electronegative character, and like uh, gaining one electron, these all will be stable. So hydrogen should be in halogen because of some of the properties, like they have they all are they are all non-metals, as well as they are non-metals, and their atomicity is 2, means they all are diatomic, whereas in the all the alkali metals they are all metals, they are monoatomic molecules, and their atomicity is 1. Yeah.
Those are your points, Anshul?
Yes.
Yes. Now I would like to ask the audience if they have any questions. I see I see Dhairya has a question. Dhairya, kindly unmute yourself. Shubham, we will come to you later.
So first of all, he just repeated his first point that if hydrogen gains one electron in the halogens group, it will be stable. So that's the repetition, and I don't think so that you need to repeat the point again to make your side stronger. And second of all, when you say that these are the metals and they are non-metals and they are monoatomic and they are diatomic, but many of the properties such as the reducing agent and many other properties matches with group 1 elements as well. So that's my counterback. So that's not always true that hydrogen is not matched with alkalized metal, and it
Can
should be.
you give an example of the properties, the similarities between the properties of alkali metals and hydrogen?
That Rutuja will give because she also needs to give her point. So yes, now she is giving that.
Okay, I would like to ask Shubham to unmute yourself and ask your question. Shubham?
Actually, I don't have a question, but I want to prove one thing. As my dear friends about the alkaline group and the halogen group has said, I would like to say that hydrogen has one valency electron like lithium and sodium, but it is a non-metal and it does not form ionic compound except an anion. And group 1 element always shows cations in ionic compounds. So I would say that placing it in group 1 would also be wrong, as it consists of only cation ionic compounds, and whereas hydrogen forms ionic compound except anions. Yes,
Are you
this
done,
is
Shubham?
it. Yeah.
Okay, please mute yourself. I would like to ask Rutuja of the group Alkali to present her point. Rutuja, do
It's
you?
okay. I request Dhairya to stop screen sharing.
Dhairya, please stop screen sharing.
And
Would
my
you like to screen share, Rutuja?
yes, okay. Yes. Okay, so hydrogen's valency matches those of the other. No, sorry, wait. Another similar property of hydrogen is its electropositive character. That is, hydrogen, like other alkalis, can form cation. And Dhairya can show the share for this.
Yes, are you talking about this share or this one?
This one.
Okay.
Yes, so as we can see, hydrogen, when loses one electron, can form a cation. So, thank you.
Are you done, Rutuja?
Yes.
Okay. Does anybody have any points to interject with Rutuja's? I see that Arushi has raised her hand. Kindly unmute yourself and continue.
Yeah, you're right. That is a well-stated statement. But it can also form an anion by the gain of one electron, which would show both electropositive and electronegative character. So why do you believe that by stating that it can form a cation, it's like it overpowers the halogens?
Are you done, Arushi?
Yeah, I'm done.
Okay. Now I would like to ask if anybody has any question against her. I see Shupank has raised his hand again. Shupank, please unmute yourself and continue.
As Arushi said, I need to tell one more point. Thus, hydrogen needs one electron to complete its valency shell. So, like the halogen, it forms a diatomic single bond molecule. But hydrogen does not react violently with metals, and it has a moderate electronegativity. So it forms an ionic compound as an anion. But such compounds are far from stable. This is very much unlike the group 17 elements. So I would prefer it to be in the middle of the periodic table. I'm done.
Okay, I see Dhairya has raised his hand. Dhairya, please unmute yourself and continue.
Yes, so I would like to reply Shubham. Shubham, why you are just saying again and again point? The point was previously said by Krishna, and Rutuja answered that it would not match the symmetry of periodic table, and as well as this the hydrogen only has one proton, one neutron, and one electron. So its atomic number will also not match. So that's all.
Okay. Now, any group has any points that they would like to share, please directly unmute yourself and continue.
I want to say one thing.
Yeah.
Okay, let's look at a bit of English here. If you need a synonym for halogens, you can say that they are reactive non-metals. Now, what is hydrogen a metal? No, I don't think so. So technically, even hydrogen is a reactive non-metal. So I don't see why I don't see why they're favoring alkaline metals over halogens when halogens have equally stated points. Yeah.
Okay. And I see Naysha has raised her hand. Naysha, please continue.
Yes, Tanish, I would like to say on Dhairya's point that he said that Rutuja had said that if hydrogen would be kept in the middle of the periodic table, it will disturb the symmetry of the periodic table. But what J.J. Thomson did was that he kept it at the middle of the periodic table so that it does not disturb the symmetry of the periodic table. So these both are contradicting points.
Okay. Does anybody have anything else that they would like to say to Naisha's point, or they present their own independent? We are open from anybody who from the audience who would like to share their points.
Can I speak?
Yes, Dhairya, you can speak.
Okay, yes. So again, I would like to reply to Naisha first. So Naisha, was J.J. Thompson's periodic table right or wrong?
See, J.J. Thomson's periodic table was partly right.
But basically, no. In science, there is nothing as partly right. You need to say right or wrong. Okay, was it right or wrong?
Wait, there were changes made in it later, but then it was, yeah, I again say it was partly right. You can't even say that it was completely right. Now you can say it was completely
Okay,
wrong.
are we following J.J. Thompson's periodic table?
Not now, but then see what Rutuja said and what I'm saying, they both are two
मुझे कहाँ के
contradicting
जाएगा
points. So
वहाँ
I
पे
want an answer for that.
That debate is
कॉन्फिडेंस
about the
गिराना
modern
बोलते
periodic
हैं
table. It's not about J.J. Thompson's periodic table. So
Excuse me,
J.J. Thompson's
Dhairya.
periodic table was wrong.
Dhairya.
So yes,
Dhairya.
yes,
Dhairya.
Tanish.
Shubham sir would like to was trying to say something, I believe. Could you please continue, sir?
Yes, sir.
Okay. So
I
yes.
see that he has muted himself. Please continue, Dhairya.
Okay. So first of all, we are not discussing J.J. Thompson's periodic table, and second of all, that periodic table was wrong. That was denied by science. Okay. And third of all, it's still why it was denied, because its position of elements was wrong. And the J.J. Thompson's periodic table was based on atomic mass, not atomic
Yeah.
number. And now the modern periodic table is based on atomic number. So that's not the valid point to say by you, Naisha.
Oh,
And say,
okay, Dhairya. I see now Arushi has raised her hand. Arushi, please continue.
So I have to say right to some people and wrong to some people. Dhairya said that in science there's no such thing as partly right. Now, again, this is also partly right, because let's say something is existing under this condition but does not exist under that condition. That means that it's partly right. However, so Naisha said that it would, because it wouldn't destroy the symmetry. That's what J.J. Thompson did. Now, right, that's correct. But let's not talk about the symmetry here, okay? I don't think the periodic table looking good is a contributing factor to adjusting the position of such elements. Now, I don't think that it should be in the middle, because it's better something and better nothing, right? And let's say somebody decides that, okay, let's do put it in the middle. What's going to happen then? That's going to be even more confusing. People won't be able to actually distinguish between the properties. Now, I am a newbie to chemistry, and I look at the periodic table and I see hydrogen standing in the middle. How am I going to know the properties of hydrogen? Am I going to know that it's an alkaline metal? Am I going to know it's a halogen? See, putting it in the middle is going to arise to even more confusion. So the real core topic is if it should be if it should be either alkaline metal groups or if it's a halogen group. Because putting it in the middle, it just gives no information away. So yeah.
Okay, Dhairya, would you like to reply to that?
sorry, I just forgot to lower my hands down. I'm extremely sorry.
Okay. Now, would anybody from the audience or from the team like to present their topics? I see. Now I'm going to ask each team individually, have they completed their part of the debate and rest their case? I am asking alkali metals group, have they presented all of their points in their entirety?
No,
No.
not. There are many points still left.
Yes. Okay. Now, please now to follow a continual decorum of the debate, we will be going on with the teams, and the audience would be allowed to interject in the end. For now, we are only allowing the for now we are only allowing the participants to interject each other. Please continue alkali metals group there.
Yeah, okay. I would like to speak that. Okay. 1 minute. I am sharing my screen. Okay.
Please share. Dhairya, please
Yes.
remove your screen. Yeah. Please continue, Rutuja.
Just a minute. Yes. So when hydrogen burns in oxygen, it burns with a pop sound to form its oxide. But alkalized metals also burn vigorously when heated in oxygen to form their respective oxides. Now we can see lithium forms a monoxide, then sodium and hydrogen form peroxide, while potassium, rubidium, cesium forms superoxide. So this is the property of all the other alkali metals that matches with the ones of hydrogen. Thank you. Finished.
Finished. Now, would anybody from the participants would like to interject Rutuja's point? That is, Arushi or Anshul would like to interject Rutuja's point. I see Arushi wants to interject. Please unmute yourself and continue.
Rutuja, do you mind sharing the screen again?
Sure.
Thank you. Right. So over here, we can see that you have taken alkali metals and you have reacted and you have used and you have shown their reaction with oxygen when they burn in air. Now I want to ask you one question. You have written peroxide. You have given like oxides of these metals. Now are these bases or are these acids? Because as far as I know, hydrogen's oxide, which is water, is neutral. So I don't think burning is a fair point to state.
Rutuja? Rutuja, would you like to contradict her point?
No.
Okay. Well, that sums it all. We have Dhairya who would like to say something. Dhairya, please continue.
Yes, Arushi, please could you repeat your last line because your voice was breaking?
Yeah, so I said
Just a minute, Tanish. I would like to repeat my point because sir has told me to.
Okay. Rutuja, please repeat.
Yeah, okay. Yes. When hydrogen burns in oxygen, it burns with a pop sound to form its oxide. Alkali metals also burn vigorously when heated in oxygen to form their respective oxides. Lithium forms monoxide, sodium and hydrogen form peroxide, while potassium, rubidium, and cesium form superoxide.
Okay.
Done.
Okay. Does anybody have any contradicting opinion?
Not contradicting, but I would like to just.
Shubham sir, would you like to say anything? Okay.
Tanish?
Dhairya, please continue with your point.
Yes, I just want to summarize the point in just one line that if the alkaline metal burns, they form their respective oxide, such as hydrogen forms its oxide, and there are elements which burns and forms its oxide, in which is a similar property among them, and that's all.
Arushi,
So I'm just going to repeat the thing I said. You guys are right. When it burns, it does form its respective oxides. But you're only looking at the things that are similar. What about the things that are different, like the whole product? Like, yeah, sure, it forms oxide, but what's so different about these oxides? I mean, the oxides of metals, are they bases or are they acids? But on the other hand, water is a completely neutral oxide, and there's a difference in physical state, and there's a lot of differences. So you can't only look at the similarities and say, oh, it's similar to them. You have to look at the whole thing, right?
Rutuja, Dhairya, would you like to take that?
No, not me.
Okay. Dhairya?
Okay, there are similarities and differences, but at least they form oxides, and they form and they at least form the similar type of compounds.
Okay. Dhairya, I would like
They
to.
are similar.
I have to.
You're saying that
Yes.
H2O is similar to H2O2 and LiO, lithium
No,
monoxide.
Arushi, we are not talking about that. At least they form oxides on burning. Each and every element in the alkaline metals, if they burn in air, they form oxides.
Dhairya,
Yes.
I would like to interrupt both of you. I see the alkali metals have gotten a very long chance. Now I would like group halogens to present their point.
Okay.
Yeah, I would like to present my point.
Yes, Anshul. Would like to share screen?
No, I'm fine.
Okay, please present your points, Anshul. And please, everybody, from now on, keep it brief. Do not extend it very long.
Okay. See, alkali metals, they like see all the alkali metals like lithium, sodium, and these all, they are not inflammable. And hydrogen and halogens, they are flammable. They are like inflammable, but alkali metals, they are not flammable. So this is one of the chemical properties.
Okay.
Yes.
Are you done?
Yeah, I'm done.
Okay. Because it causes confusion if you don't say you're done. Please say after you have completed. Kindly say that you have completed.
Yeah.
I would like to ask if anybody has any question for Anshul. I see that nobody has a question. Oh, okay. I see Dhairya has a question for Anshul. Dhairya, please unmute yourself and continue.
Yes. Yeah, I accept that they are inflammable, but at least they burn. At least they burn in air. Like alkali metals burns really vigorously and even hydrogen burns really vigorously in air to form H2O, to form water. So yes, so the whole point is not true that even they have a similarities in burning, if it's at least not inflammable.
Area. What I'm saying that even halogens burn, but they are inflammable, and alkali are not flammable.
Okay. So,
I'm talking about the property, not about the reaction. Alkali metals are not inflammable, but they burn. I understand, but hydrogen and halogens, they are inflammable.
okay, so both have a similar properties. They
No,
burn like each other. They are flammable. So both have similar properties. So even this again they neutralizes.
no, it does not neutralize. They burn, but they are not flammable. But these are flammable and they burn. So the chemical property is different, and the reaction is same.
Okay, that's it.
Okay.
And
Moving on. Now, Arushi, would you like to present any point?
Yes, I would. So we previously, I don't remember who it was, but you guys talked about how hydrogen, it has an ionic bond. If it has an ionic bond, it also has a covalent bond, which is what halogens have. So to really go in deep into it, the physical properties of it, the physical properties are actually similar. Like valency, both have a valency of one. But you can't only look at the physical properties, and I've already said that once again. The thing why I think it should be in halogens is because it has a variety of properties, and I'm sure that in the starting, when the whole thing was being formed, I'm positive that they actually not only looked at the physical properties and actually also looked at the chemical properties, which are actually very similar. And in fact, there are so many articles in which people actually are trying to prove that even hydrogen behaves like a halogen. And yeah, I'm done.
Dhairya, please unmute yourself and continue.
So first you talked about the bonds that hydrogen has ionic bond and a covalent bond. So even hydrogen is the first element which even goes under hydrogen bond. And second of all, currently hydrogen is in the first group. So obviously we have an upper hand, and scientists must have thought something else, that why to keep hydrogen in the first group. And that's all. I conclude.
Yeah, but that's
Okay.
the thing, right? We're just believing whatever's written. We're just believing, oh, since the periodic table has it's in alkali, let's just believe it, because obviously the scientists must have thought. But this new generation is contradicting it. Like me and Anshul were contradicting it. We refuse to accept what's written in the textbooks and what's written in the internet, because we believe that it can even go deeper. I mean, if it has both properties, then why not? Why not actually go into a deeper study rather than just accepting what our previous generations have done? I'm done.
Okay. Now I would like to ask to each and every group, Arushi, I would like Arushi and Rutuja to unmute themselves.
Yeah.
Rutuja?
Yes.
Yeah. Now I would like to ask, is your team completed with all their points, or do you have any more points?
No.
No, a few
Yes,
points
we have
left.
many more points.
We have not finished completely.
We are not
We have
Arushi,
stated
have you?
our points. But reflecting on there, we might have some more information.
Okay.
So
I would ask Arushi to mute herself, and now I would ask Dhairya to present points, and I would ask to keep all of your points brief, and do not keep it very long. Just keep it brief. Keep the points brief.
Okay. So I want to screen share. So just tell me that if it's not visible. Is it?
Dhairya, it is visible. Please continue.
Yes. Uh, just a second, if you don't mind. I'm just searching a screen share. Permission. Yes. So wait. Yes, so hydrogen also has one more property which is same as alkaline metal, the reducing power. The reducing power, both alkali metals and hydrogen acts as the reducing power. So I want to prove that by just showing two reactions. So CuO plus H2O gives Cu plus H2O, and the second reaction, um, maybe okay, yes, I just want, and the second reaction which is in our textbook page 97, CuO copper oxide plus sodium gives copper plus Na2O. So they both have the same kind of reducing power, both hydrogen and the alkaline metals or the other elements of group 1. Thank you.
Okay, Dhairya, do you have any more points that you would like to present?
Currently not now, but yes, I will the if the other team interjects.
Okay, the team is not interjecting as I can see from here. Uh, Ru- Rutuja, do you have any more points you would like to present?
Yes. I see the combination of non-metals with hydrogen. So hydrogen as well as alkali metals react with non-metals like oxygen, sulfur, and chlorine to form their respective compounds. For that, I would like to share the screen.
Dhairya, please cancel screen share. Rutuja, please continue and keep it brief.
Yes. As you can see, hydrogen reacts hydrogen as well as alkali metal like oxygen, sulfur, and chlorine. So I have also given another example of sodium, which also reacts with oxygen, sulfur, and chlorine. Thank you. I have finished.
Okay. Have you finished with all of your points?
No, I still have one point.
Dhairya, would you require screen share for it?
No, I will not be
Dhairya,
required.
please present your point fast and then keep it brief.
Okay, so one more property that both hydrogen and alkali metal, all the elements of the first group have similarity in them both. That both burns with action of air. In the other elements of the group one vigorously burn in action of air, and even hydrogen does the same. Thank you.
Okay. Now I will give chance to Shubham. Shubham, please unmute yourself and continue.
Yeah, I would like to state one more thing. As
Yeah.
hydrogen is the only element which has one electron, one molecule, atomic mass, so it can easily donate one electron and gain one electron. So its redox reactivity is zero. So I think that it should still be in the middle of the periodic table.
Okay. Okay, Shubham. Thank you for your point. Um, Rutuja, do you have any more points that you would like to present? Rutuja? Rutuja?
Yes, I wanted to ask that can we tell a point like why shouldn't it be in halogens group?
Yes, you can.
Okay, so hydrogen should be in halogens because oxides of hydrogen, that is H4, is a neutral oxide, and oxides of halogens like chlorine, ClO2 or Cl2O, Cl2O7, etc., are acidic in nature, while oxides of alkali metals are acidic in nature.
Okay,
So I
Rutuja.
have finished.
Oh, okay,
Thank you.
Rutuja. From now, I would like to ask the halogen group if they have any point to contradict this.
Yeah, I
That
want to.
includes Anshul and Arushi, but I can only see Arushi's hand raised, so I'm going to ask her to unmute herself and continue.
Okay. So similarly, if the oxides of halogens are acidic in nature, then the oxides of metals are also basic in nature. So when you guys are continuously saying that it's burning in air, when it burns in air, when hydrogen burns, see, okay. So the oxide of hydrogen is a neutral oxide, which is water, and the oxide of lithium, a lot of alkali metals, is basic in nature. So how can you try to prove ourselves right? Like how can you prove yourself right by proving ourselves wrong? Because you said that it's acidic in nature because the alkali metals oxides are basic in nature. So yeah.
Okay. Anshul, please continue with your points.
Yeah, I had the same point to say.
Okay, Anshul, thank you. Dhairya, do you have any point?
Yes, that you told that alkaline metals, yes, that they are basic in nature, and the halogens, the oxides of the halogens are acidic in nature. But the property of hydrogen matches with the basic one. It's small, near, or I can't say near, but it's small, similar to the basic ones, or it's small, similar to the oxides of the first group, of the elements of the first group. So I don't think so. That's a valid point.
Neutral
That's all.
is neutral. Neutral is like 50% away from acid and base. You can't say that neutral is more similar to basic.
No, I'm not talking about neutral is more similar to basic. There are many other oxides except you are just talking about H2O, but there are many other oxides from which it's not always neutral. There are like H2O2, even there are H2O3, and there are many more. That doesn't mean that always only water is basic, but only water is neutral, but that doesn't mean that all the compounds are neutral or the oxides are neutral. And even it is mentioned in our textbook, so you can refer to that as well, Arushi. That's all.
Okay. Now, final time I am asking, does anybody have any more type of points that they would like to present? I would like to ask the audience if they have any points they like to present, and the team that if they have any points to present. Are you presenting any point, or have you just raised your hand and forgot to? Okay, I see. I can now make out that nobody has any point they would like to present. Now I would like to ask Shubham Sir to say any words if he would like to.
Hello everyone. Am I audible now?
Yes.
Yeah. So it was wonderful, fantastic to hear all of you speaking so brilliantly, elegantly from the scientific terms and explaining the points you're supporting, especially the questions raised by Krish that why can't we keep this in the middle, and from Arushi that since it is not either supporting fully alkali and not halogens as well, so we should put it in the middle. So these things are really nice, fantastic. So I would like to hear few things more from you guys. If you can tell a little bit about what are the bases on which we are classifying the periodic table. If you can put some light on this, the basis of periodic table, then most of your questions would be resolved very soon.
Okay.
So any of those groups can put few points about what is the base for periodic table, how is it made. That would be wonderful to hear.
I see that Rutuja has raised her hand. Please
Okay.
Yes.
unmute yourself.
So, sir, the elements in the periodic table are arranged according to the increasing atomic number. I'm done.
Okay.
Now I see that Arushi has also raised her hand. Arushi, please unmute yourself and continue.
Yeah, she's right. They're arranged on the basis of their increasing atomic number. Also, something like the electronic configuration, the valency, and a lot of the properties also match. Um, yeah, it's not only atomic number is a very valid point, but there's also valency which matches. There's electronic configuration which are similar as we discussed. Sometimes even the like atomicity for the atomicity for certain for halogens let's say is 2. So even like certain different properties matches with things like that. Yeah, that's it.
Oh, fantastic. Thank you very much to share.
We have one more point from Anshul. Anshul also
Okay.
wants to say something.
Yes, thank you, Tanish. Sir, we are arranging the elements in the periodic table according to the, what do we say? See, if you are placing an element in the group or in that group or it's a period, you need to see all the properties of the element, like physical properties of the element and like chemical properties, it's arranged in a pattern, like these are the elements of the same characteristics, these are the elements of the same characteristics. Accordingly, you need to even analyze the element itself, like is it matching the properties of this element, is it matching, like after. And there are some elements, for example hydrogen, that it contains the similar properties, the properties of halogens, the properties of alkali metals, and it's a big issue. So you need to like analyze the element and then you need to classify the position. It's that basis, the means the reaction with that element with another element, the, as I'm repeating my point, physical properties and chemical properties. And even you need to see the atomic number, not the atomic mass, and it's that way. Thank you.
Yeah. Thank you. Thank you very much, Anshul. I can see very nicely explained by Rituja. Dhairya putting very nice questions and also, telling others that what they have spoken is not all good. So it was very nice. So as you discussed, I can see that, what we have come till now with the periodic table, it is all about certain quality which is independent of the external environment like temperature, pressure, we put on that, and it should not change its qualities immediately, So that's why you see initially, though we consider that electronic configuration is there, but as we see, as we heat any element, or we provide certain conditions like put catalyst in that its presence, then what happens? That valency changes. Not the valency of the electron, but the presence of electron in that particular cell changes. So considering this initially, Mendeleev's, he chose it would be better if we go deep. So he went into nucleus and he decided, why don't we take the whole mass of the nucleus, isn't it? So he decided we should choose something which is not changing so randomly. But later on, as you see, there were anomalies. There were some disturbances like potassiums and argon's presence and their position in the table. So later they came with, okay, atomic mass we cannot consider all in all. And there were, you read and you write also in exam, 6, 7 kind of, challenges were there with Mendeleev's table. So then they thought, why don't we come with some more solid where such kind of contradictions can be reduced? So they thought, okay, let us consider something better. So they came up with the atomic number. Atomic number means the position of positive charge in our nucleus. Okay, so number of protons, positive charge inside the nucleus. And then they came up with this idea and they summarized, okay, now if we consider this as our meter or standard with which we'll consider the positions of different elements in periodic table, then it will be wonderful. We can solve so many problems. So now any one of you can present certain points. What are the still contradictions in our recent periodic table? Very first, you all are already discussing, I think, right? Position of hydrogen.
Yeah.
Yeah. And
So there
another
was
one?
also isotopes.
Can I please? Okay.
Yeah. Anyone?
Isotopes. The isotopes aren't like specified.
Right. So you see, gradually it's improving, isn't it? Is it correct?
Yes, it is improving.
Yeah. So that's how I see, and I think very nicely Tanish, right? Tanisk is running this show very nicely, giving chance to everyone and hosting it very nicely. Very good to see. And I would like to see what he has observed. He can also share certain points. And I would like to hear what he has collected.
Sir, so basically the whole point of this debate was about the position of hydrogen in the periodic table. But what my independent opinion to all of this, my opinion is that it should be in the, it should, for now at least, it's in the first table, because for first group, because what because see, they have done certain type of research to get to this point. Okay, they have proven certain facts, and those facts have certainly said that hydrogen itself, it's a unique element. It was the first elements in the first element in the world, the first element in the universe that came by, because of the whole because of the whole with the creation of universe, we had when the first when the first electrons were trapped in the orbits around nucleus of protons and neutrons, the first elements formed were the hydrogen, and that's what made it a very unique element according to my view. And what I think personally is that the whole the entire element of hydrogen should have been in itself independent of the periodic table, to say the least, because that's the only way you
That's
can justify the
interesting.
position of hydrogen.
That's
It needs to
interesting.
be independent from the periodic table. That's my point of view. But as a moderator of this debate, I can say that for now they have done a lot of research on this topic. They have conducted multiple experiments, and then they have reached to the statement that it should be in the first group. So it belongs to the first group and the first period because they have done certain more people more experienced than us, people who have better qualifications have thus they have done this research for hundreds of years and they have come to this conclusion that it should be in the first group.
Very
That is
true,
because
very true. Yeah.
that's the most approximate place it can be. It is such a unique element that it cannot be it cannot be part of one group. But if you had to put it in a periodic table that is used for studying and studying the elements, that in that case then they put it in the first group of the first period because they did some research and then they found out that this is the most approximate place that it should be.
Right, right. Okay, very good to hear. Yeah, that's true. That
Huh.
when what we are seeing as of now in our periodic table, that has come after so
That
much
has come
research.
after hundreds of mistakes. Now there were multiple
True.
periodic tables. J.J. Thomson's periodic table, Mendeleev's periodic table. That came down to the modern periodic table. What do you in the next 50-60 years, let's say in the next span of 50-60 years, we think that the modern periodic table could also be disproven by a new periodic table.
Right. There are chances.
Yeah.
Correct.
As of now what we can say is that it's a part of the first group and the first period because we have reached the point where we have made it the part of the first group of the first period. Now 50-60 years later some new experiments could have been done to disprove this.
Right. It is
But
possible.
from the facts that have been given to us by multiple scientists over hundreds of years, I can safely say that as of now it should be in the first group of the first period because of the points that they have said over multiple years. So you cannot just disprove hundreds of years of proven scientific methods to justify the position of hydrogen. Hydrogen is a unique element, but more experiments will have to prove the position of hydrogen. It is going to change. Certainly, it's not going to our periodic table is not going to remain the same in the next for the next 50-60 years. It is certainly going to change. But when it changes and they find the perfect position for hydrogen, it is going to change. So what the next generation or the next to next generation will may have some hydrogen where it is independent of the periodic table, or it is
right
some other group.
Okay, very nicely said and concluded as well, I'll say here. So I hope you guys would have got some idea, right, what Tanish is trying to prove and put his points here. So we say that whatever knowledge we are gathering, we are acquiring, you all are in 9th standard. So we see that knowledge is either received or there is another approach, like if we were not taught by our teachers, we were not told by the scientists what are the things as it is, then we all will have to do separate research, isn't it? We'll have to find out ourselves our own periodic table. And that would have been, mayhem. It would have been very, Herculean task. It would be difficult for us to find out.
Ascending process.
True. So very true. So that's what I'm coming to. There is descending process and there is ascending process. So it is very easy, convenient, time saving, and very rightly digestible if we take the knowledge from that source who has already done that work, who has already, researched that theme, that particular area, and find out the facts. And now he is giving us directly. So that's what is happening. Whatever points were shared by the halogen groups, like Arushi was there, Dhairya also, right?
Yeah.
Dhairya was there, and for another site, I think there was Anshul. Yeah, Anshul was there, right? So very rightly told that there are certain properties which we see in hydrogen which doesn't fit it in first group, which is alpha group. And it disproves that why should we keep it there just because it is having one valency electron, or the atom is number 1, but its properties are totally discerning, totally not proper fit for that table. So here what we have taken, we saw the very first thing, what was the basis of our table, what was the basis for making this correct table, and how it evolved actually. And now what we understand, what Tanish has concluded very nicely, that so many people have already done so much research, and considering all the things, all the challenges, contradictions, and they have not to think just only for hydrogen. They have to think of so many other metals as
Multiple
well.
elements.
True. You see, like very one big contradiction might be inert gases itself. Inert gases are placed in that particular group where they are not supposed to react, but we see there are compounds. So this itself is a contradiction. So such things you'll observe as you are read now. Higher mathematics you'll study. Similarly, you'll study higher chemistry, physics. So many things you'll see. So such contradiction can be resolved if we consider and discuss these things with the authority. Who was that scientist who worked, and right now, who all scientists are accepting, which means that is the descending process. The person who has done research, he has put the lot of work, lot of amount of time he has put there, and now he is saying this is this. Till now, whatever research has been done. So if you think in this manner, then there would be very less challenges that why alkali, why not halogen, or why halogen, not alkali. So in that way, if you consider this periodic table, at least for hydrogen right now, so it would be very easy and palatable for all. So that's from my side. And if anyone want to ask any question or comment, they are more than welcome. Please share your thoughts. Very happy to hear.
Sir, I would like to say a few things. Sir,
Yes.
thank you for your time and thank you for coming to this debate. But now, sir, I would like to ask Naisha to present a point that she wants to say
Yeah.
because currently we have to try and finish the event by 12:15, 12:20. So we are going to ask Naisha to complete her technical talk.
Sure, sure. Yeah.
Thank you, Tanish. So after having such a wonderful discussion by alkali and halogen team, we got very relevant points. So let me conclude this discussion now. There are certain properties of hydrogen which are also different from the alkali metals as well as the halogens. So let's take a look at those properties. So hydrogen atom has only one shell, but alkali metals and halogens have two or more shells. Second of all, oxide of hydrogen, which is H2O, is neutral oxide. Oxides of halogens like Cl2O, etc., are acidic in nature, while oxides of alkali metals like K2O are basic in nature. So these were some points of hydrogen which were different from those of alkalis as well as of halogens. Thank you.
Okay, Naisha, thank you for your points. I see Anshul has a question for Shubham sir. Anshul, please unmute yourself and continue.
Yes, thank you, Tanish. Shubham sir, I want to ask that what's your view on the position of hydrogen, alkali metals or halogens?
Oh, so this is very fantastic question. I see those who are very intelligent. They want to put everyone in the box to know their opinion. So just okay. So actually, I have studied in electronics and telecommunication for my engineering. So in my college days, I was very fond of electronics. So what happened during reading that time, I had good discussion with my teachers. I also read good books, and I came to know that whatever we see in chemistry, we see it as a perspective from the perspective of mostly the chemical properties or qualities, right? Isn't it? Like
Yes.
all of you were discussing their properties when it is heated, when they are reacted with oxygen, when they are put with some reaction is done to alkali to base or acidic compounds or acids. So whenever we see elements, we always see what are their properties. But when we study little more in deep, then we come to know that there are certain things which are presenting those qualities, like without a particular form, there cannot be quality. If Anshul or Dhairya are there, then there would be their voice, there would be their form, there would be their presence, but for that their existence is required. Similarly, when you come to discuss about chemistry, whatever we see as properties or qualities of matter or compounds or elements we are right now discussing, that comes through the particles which are there inside. So what right now you see in atomic number or whatever you see as a valency, that quality is coming because of that particle is there. So if you read your book, you will read that recent what periodic table you all are studying, that is based on not only the atomic number, what they have come up with, every atomic number is having particular nuclear force, and that nuclear force binds the electron outside. And whenever any electron is put in such a condition that its valence electron or the outermost electron is supposed to leave, and after leaving, when that force, that heat, that temperature condition is removed, then it comes back to its position. So at that time it emits particular light, or you'll read in a book that wavelength is produced, right? Whenever valence electrons goes out and then comes back to its position, it releases that energy which it has got, that extra energy.
Yes.
So if you see, periodic table means periodicity. So what should be that periodicity of, or the quality of that element which is represented throughout that group? So in that way that table has made. So my personal opinion would be, if we observe the wavelength of electron which it emits providing the heat or energy, then when it comes back to its valency cell, then what is that wavelength which it is giving out? So if you see, the groups are arranged in that way. So my personal opinion is, as of now, what we understand in science, with all the knowledge what we have heard, what we have received, read, right now its position is correct, because there has not been much debates on that, the wavelength it emits when it comes back. So that wavelength is also having regular order. So I consider right now, and respecting all the scientists, as Tanish said, yeah, we should respect. They have done a lot of work, but we have all the rights to question. So we can question, but as of now, we want to study and go high. We want to go further, so we will have to accept. So in my personal opinion, I accept what it is right now is correct. So that's my opinion.
Thank you, sir. Seriously.
Thank you very much for
Thank you, sir.
asking.
Thanks a lot.
Thank